I usually find it's a little easier to do with decimals. There's like no problem just typing your answer in to see what the decimal is for that. So we're going to do it in exact form. And exact means you don't type it into the calculator to get a decimal approximation. You leave your answer as 7 log base 3 of 8 there. So let's just look at a few examples here. So we have some exponential equations that we're going to look at first. And we might not even do all of them so we can get through a little quicker. All right, so you basically just solve this like you would solve an equation, and we got a new tool to deal with exponents or exponentials, and that is logs, right? So the first thing we would need to do here is add 2. You have to get your exponential by itself. So that would give us 4 to the x power would equal 11. Okay, and we are trying to solve, yes, because I can't add apparently. Sorry. All right. So we are trying to get that x right there by itself. We got to get rid of the 4. How do we get rid of that 4? It is a log base 4. Okay, because it is not x to the 4th power. That's where we would use a root. It is 4 to the x power. So whenever we have a number that is our base, to get rid of that, we use the log that has that same base. So that would cancel the 4 over here. We'll do log base 4 over here. So x equals log base 4 of 9. That is a number, right? Because it doesn't have any variables in that expression. The x is by itself. You can type it into your calculator, log base 4 of 9. You can get a decimal for it. They've asked us to do exact form, so we're not going to do that. We're just going to leave it as it is. Okay, questions? All right, for B. Lucas, what would I do first? Perfect. So I will have 2 to the x plus 3 equals 21. Okay. Lexi, what would I need to do next? I got to do log base 2 because I got to get rid of that base on that logarithm. So that'll give me x plus 3 equals log base 2 of 21. And then, Tyler, what's the last thing I would do? Subtract that 3. And so x is going to equal log base 2 of 21 minus 3. You cannot, because that you're doing log of that 21. So if there were parentheses, it would be on the outside, yeah. And let me just show you real quick. There are going to be some times whenever we get to our, there are going to be some times whenever we get to some application where we are going to want to type this into the calculator to get a decimal because we don't really know what that number is. So, you can do math, log base 2 of 21 minus 3. This answer is x equals 1.392. But whenever they say exact form, it's not the decimal for that. So we're going to leave it like this. Okay, questions? Let's go ahead and do C because they put an E in there, which makes this a little bit different. Not much, but a little bit. No. No. Although it is a little similar to your inverses, like when you switch your x and y's and solve, so that will be on there, but you won't have one where you get a number answer. Okay. Let's see. Solana, what would I do first on C?
Would you minus the 3?
Yes, perfect. Okay, so that gives me negative 10 equals negative 4 e to the x. Okay, Emma, what do you think we do next? I do need to use a natural log, but I can't do it yet. Because if I do a natural log right now, I'm going to have natural log of negative 4e to the x power. These are not going to cancel each other out because of that negative 4. So we have to get rid of that negative 4 first. How would we do that? Divide. We're going to divide by negative 4. And that is going to give us 5 halves. They're probably going to stick with fractions instead of doing decimals right there. Equals e to the x, and I'll show you why in a second. And e to the x, now we can use that natural log. Because natural log is a log with the base of e, so it'll get rid of that base. So we'll do natural log on this side and natural log on this side. So x will equal natural log of 5 halves. I don't think they're going to leave the answer like that. They could. If it's free response, definitely just leave it like that. But I think they're going to give it to you in a different way. How else could I write the answer? Both of those are true. Like we do 2.5 or 2.5. That would be true. I don't think that's how they'll leave it. It's from what you did last night. If I have division, what can I do? Natural log of 5 minus natural log of 2. Now, I'm not sure which way they would give you the answer on that. It could be either one, though, because what you'll find sometimes is like on multiple choice questions, you might get what you think is the answer and then it's not there. It might be that you were correct. They've just messed with the way the answer looks a little bit. Okay, we okay here? All right. And those are numbers. We can type them into the calculator. If it says exact form, that just means don't type it into the calculator and get a decimal. That means your answer is going to be probably have logs or exponentials in the answer. If they ask for a decimal approximation, you would type it in. The exact form does not necessarily tell you, like, this is a correct answer and this is a correct answer, and there's not necessarily, like, one better than the other. So this would just be a situation where, like, you want to look and see what answer choices you have. It's probably going to be multiple choice. Or when you're working on the homework tonight, it is not multiple choice, but if you'll check the answer key and just make sure you can get your answer to match what he has as the answer, that will sort of give you practice of that multiple choice sort of scenario. Okay. Next problem. We want to solve this for x. So we're going to solve it like a regular equation. The log has to be by itself before you can do anything to get rid of the log. Okay. So what should we do first here, Granger? Perfect. We'll subtract that 4. So we will get 2 log base 3 of x plus 3 equals 6. Okay, Anaya, what needs to come next? Yes, we got to divide by that 2. Because a lot like the last problem, we can't get rid of that log if there's anything on the outside of the log. So we got log base 3 of x plus 3 equals 3. Okay. All right, Tyler, how are we going to get rid of that log base 3?
3 to the power.
We do 3 to that power, which will cancel here. 3 to the power here. So I have x plus 3 equals, what is 3 to the third? 27. 3 times 3 times 3 is 27. And last step, we just need to subtract that 3. So x equals 24. This is a much, I sure do like it whenever I get an answer that looks like that instead of having an answer of natural log of 5 minus natural log of 2. The log equations are more likely to end in a whole number or a more reasonable number than the exponentials. They usually end up with a log. But it could go either way. All right, we okay here? All right. Let's see. Maddie, what would we do first on B? Yes. How are we going to get rid of that? We're going to subtract. Very good. Alright, so we got log base 5 of 2x minus 1 equals 2. Alyssa, we now need to get rid of that log. How are we going to do that? Perfect. 5 to the power gets rid of that log. Have to do it on the other side as well. So we get 2x minus 1 equals 5 squared is going to give us, that's 2 to the 5th. 5 squared is 25. Because we're doing 5 raised to that second power there. And then we just have a simple two-step equation to solve. We're going to add that 1. 2x will equal 26. We'll divide by 2. X equals 13. Yeah, I like them a little better. Definitely the answers I like better. I do not like to get ugly answers. But it does happen. For example, C is going to have an ugly answer. What would we do first for C? Multiply by 5. That'll get rid of our 5 here in the denominator. So we got natural log of 2 minus x equals 5. I need to get rid of the natural log. What's the base on the natural log? It is, there's an e there. It's not written, but it's an e. So how do I get rid of a natural log? E to that power, e to that power. So if you have a natural log problem, they don't turn out as nicely as the first two that we did. Because we're going to have 2 minus x equals e to the 5th power. And e to the 5th power, e is like 2.178 whatever. And we can't do that without the calculator. So for an exact answer here, we're going to have an e in our answer. Which feels like a variable, but it is representing the constant. So it's like having pi. It's really just a number. All right, so we just got a couple more things to do. We need to subtract 2, which you really can't do because you got e to the 5th, so you're just going to write that as e to the 5th minus 2. And then I need to divide by -1, which just changes the sign of everything. So x equals negative e to the 5th plus 2. They will probably write that as 2 minus e to the 5th if I had to bet, but either one of those is correct.
So why do we divide by negative?
Because you still had that minus right there in front of your x is like having a -1 with that x. So the 2 right here, when we got rid of it, that minus was still there. So we had to divide by -1 to get rid of the negative in front of the x. And that doesn't feel like a number answer, but it is. If we type it into the calculator, we have 2 minus e to the 5th, which is, no, that's okay, yeah, -1.464. There. It is possible to get what you call extraneous solutions for this. I don't know if he puts these on here because he doesn't mention it in his notes, but like I got that negative answer. You cannot take a natural log of a negative, but if I plug this in, it's 2 minus -146, and so 2 minus a -146 is going to be like positive 148 something. So that's okay. If you find yourself plugging your answer back in, 2 times 13 minus 1, and you get, there you're going to get 25. If you find yourself plugging your answer back in and you're getting a negative inside the log, it's what we call an extraneous solution. It doesn't work, and you would throw that answer out. It doesn't happen much, and I don't think he's really addressing it here. So this makes me sad right here that Coach Wood is not here with us today, because if he walked by our room and he saw this right here on the board, does anybody know what he would have to say loudly? He would have to say that you got to drop the logs right here. Did he do that for you? How many of you had Coach Wood? Did he not put poop emojis on the board and talk about dropping logs?
Billy Brown.
Yeah, I doubt Coach Brown did that. Yeah. Yeah, so anyway, let's go through this. Now, with our logs, it does note here, in either case, we need to check for extraneous solutions. Log properties can sometimes lead to solutions that are not in the domain of the original graph. Really important right here, to drop a logarithm, we cannot just drop all of the logs there. We have to have one log on each side. I wish he had put an easier problem here. And I don't see those. So, like, let me give you, like, what would be the easiest problem if we put this here. Like, if I have log of 2x minus 1 equals log of 5. Right there. So, log of 2x minus 1 equals log of 5. In order for those two things to be the same, the numbers on the inside have to be the same, right? Because you have a log on both sides. That log has a base of 10. Essentially, what you are doing is you are doing 10 to the power on both sides, and that is going to cancel out both of the logs. And you will have 2x minus 1 equals 5. And you will add 1, and you'll get 2x equals 6, and you will divide by 2, and x will equal 3. So that would be your very easiest problem whenever you had just single logs on either side and you just drop both of those logs. And Coach Wood thinks it's really funny to say, drop the logs. So he likes to use that phrase a lot. So let's look at A right here. And we'll do A, B, and C. We may not get any further than that because we got stopped. Right now, what you cannot do on this, don't write this down, it is incorrect. You cannot say 3 plus x plus 4 equals 5x minus 2. Okay? You cannot drop all those logs. Okay? Because if we did this, sorry. I don't know what I did there. If we did this, if we dropped all those logs, that's not mathematically correct. In order to drop the logs, we have to have everything inside of a single log on either side, and then we can use that inverse, or we can do like 10 to the power and get rid of both of them, right? We cannot do, like if I do 10 to the power over here, it's 10 to this whole expression, and you got two separate logs with addition, it doesn't cancel there. So, we've got to put the logs together first, which is where those properties we learned yesterday come in. Right, so if I have addition, when I put that stuff together, what operation do I use? Multiplication. So I'm going to have log of 3 times x plus 4. Keep parentheses around that x plus 4 since it's an expression with more than one term, equals log of 5x minus 2. And now, the base on both of those logs is 10. I can do 10 to the power on both sides. It will cancel both logs. And I've got just an expression that's an equation left. I'm going to go ahead and distribute that 3 here. So I'll get 3x plus 12 equals 5x minus 2. And I just need to get the x's together. I would subtract the 3x. So I'll get 12 equals 2x minus 2, add 2, 14 equals 2x, x will equal 7. You do want to check on all of these, especially when you're using log properties. You cannot take the log of a negative number. So you want to plug your answer back into each of your logs and make sure you're not getting a negative number, because if you are, you'll have to throw that problem out, or that answer out. But 7 plus 4 is going to be positive. 5 times 7 minus 2, also positive, so this answer is okay. Okay, let's do B, and then we're going to stop. So if I want to combine the two logarithms on the left side, what operation should I use this time? Division. So I would say natural log of x plus 1 over 3x minus 5 equals natural log of 7. And I need to get rid of both of those natural logs, so I just do e to the power, it cancels them both out. Now I've just got x plus 1 over 3x minus 5 equals 7. That equation's harder to solve than the last one that we did. What should I do? Good. I can't solve for something whenever it's in the denominator. I'm going to rewrite this so I can be a little bit neater. I can't solve for something when the x is in the denominator. So I'm going to multiply both sides by 3x minus 5, which will cancel 3x minus 5 on this side. I will have x plus 1 equals, I can distribute my 7, 21x minus 35. And now we're just down to a simple equation. We'll subtract that x. 1 equals 20x minus 35. We'll add 35. 36 equals 20x. We'll divide by 20. So x will equal, see, 36 over 20. What goes into that? 4 goes into both of those, right? Is there anything bigger? I don't think so. So divide the top by 4, I'll get 9. Divide the bottom by 4, I get 5. So I get 9/5. You do want to plug back in to make sure you're not getting negatives. 9/5 plus 1, that's positive. 3 times 9/5 minus 5. 3 times 9 over 5. 27 over 5 minus 5. 27 over 5 is bigger than 5. So that's also positive, so this is going to be an answer here. Okay, so we're stopping here so we can look at our homework.